In previous lecture, we have studied different kinds of vectors. Today, we will discuss about one of the kind of vector that is called unit vector. A vector whose magnitude is 1 and a vector which is dimensionless, having no dimension, that is called a unit vector. So, considering some example of the unit vector, the magnitude of each unit vector is equals to unity. That is magnitude of I cap, which is actually a unit vector in the direction of x-axis, mod j cap, which is a unit vector in the direction of y. And similarly, we have a k unit vector k, which is in the direction of z-axis. All have the magnitude 1. Such vectors having magnitude equals to 1 are called unit vectors. As we have discussed in the previous slide, that there are some basic example or some standard example for the unit vectors which are in the direction of x, y, z, or which are in the direction of which are known as Cartesian unit vectors. These are I, j, and k. They point in the direction of x, y, and z axis represent respectively, as you can see in the graph. Now the next definition or the next type of a vector is scaling vectors. How we can scale a vector? If we have a vector v and we want to double that vector, so we lengthen it up in the same direction, right? Like if the value of v equals to 2, then or we can multiply it with number 3, a positive number 3, then it will 3 times 2, राइट सो द आंसर विल बी 6. तो अगर आपके पास एक ओरिजिनल वेक्टर की लेंथ 2 है और आप उसको मल्टीप्लाई करें 3 के साथ, तो वो 6 बन जाएगा, पॉजिटिव डायरेक्शन में है और जिस नंबर के साथ मल्टीप्लाई किया वो पॉजिटिव है, तो ऑब्वियसली वो सेम डायरेक्शन में बढ़ेगा, राइट? तो उसकी जो वैल्यू स्केल्ड अप होगी वो पॉजिटिव डायरेक्शन में भी. सिमिलरली इफ वी हैव a vector with value 2 और हम उसको मल्टीप्लाई कर रहे हैं विद द नेगेटिव नंबर -3, तो वो स्केल्ड होगा इन डाउनवर्ड डायरेक्शन और उसकी जो वैल्यू डिक्रीज होगी, क्योंकि जब आप उसको 2 को मल्टीप्लाई करेंगे -3 के साथ, then the answer will be -6. So it will in the decreasing direction. So as you can see in the definition, if C is a non-zero scalar and V is a vector, the scalar multiple CV is the vector whose length is magnitude C times the length of V, and the direction is same as V if C is a non-negative number, and opposite to V if C is a negative number, right? If C equals to 0, then CV equals to 0. अगर हमारे पास स्केलर ही 0 होगा, it makes the vector 0. So that vector becomes the 0 vector. We have some properties related to vectors. As you can see, A, B, C are the vectors, A and B are the vectors, and C and D are the scalars. So in these properties, we are actually depicting the relation between the vectors and the scalars. If two vectors are added, then their position can be changed. That is actually the commutative property, and vectors can be represented by the bold letters, whereas the scalars are not represented by the bold letters. Okay, there are some scalar. In second example, in second property, we have three vectors actually, because all of the three letters are in bold case. So a plus b plus c equals to a plus b whole bracket plus c. That property is called the associative property. If a vector is added in a zero vector, then it remains the same vector. If a vector is added in a vector with the opposite direction, then they nullify their effect and we got the zero vector, right? Zero stands for the vector here. Zero is not the number here. They are representing vector. Two vectors can be added, right? So their sum is again a vector. Similarly, in the fifth property we have, if we multiply a scalar with the sum of two vectors, then it will be distributed over addition, that is CA plus CB. Here C is not bold, that means it is a scalar. So if two scalars are added and multiplied with a vector, then it is also defined as CA plus DA. C and D are here scalars. Similarly, if CD are multiplying with a vector A, then we can change their bracket position. Or if the value of C equals to 1 and it is multiplied with a vector, then the vector remains same. Okay, we have an example performing some operations on the vectors. Suppose that we have a vector u in 3 coordinate system. So its x-axis is along -1, y equals to 3, and z equals to 1. Similarly, we have another vector in 3-dimensional space. V equals to 4, 7, 0, the triplet set. Now we have to find out 2 times of u vector plus 3 times of v vector. How we can solve it? By substituting their values. We 2 times u means कि हमने u को डबल कर दिया. इसी तरह 3v means कि हमने 3 को, it is actually a scaling vector, हमने उसको 3 times बढ़ा दिया. और बढ़ाने का क्या मतलब होता है? हम उसको मल्टीप्लाई कर देंगे उतने टाइम्स. ठीक है. और जब एडिशन की बात आती है, 2 वेक्टर्स कैन बी एडेड, राइट. जिस तरह नंबर्स को हम 2 नंबर्स को ऐड कर सकते हैं, इस तरह हम वेक्टर्स को भी ऐड कर सकते हैं. लेकिन वेक्टर्स को ऐड करने का मेथड है, और वो मेथड क्या है? कि x coordinate can be added into the x coordinate and the y coordinate is added into the y coordinate. Similarly, z coordinate will be added into the z coordinate, right? So -2 will be added in the x coordinate of the other vector, which is v vector, -2 plus 12. Similarly, we have 6 plus 21, 2 plus 0, and we got 10, 27, 22. The triplet set. 10 represent the x coordinate, 27 represent the y coordinate, and similarly 2 represent the z coordinate. And these coordinates are for the vector 2u plus 3v. Similarly, in the B part, we have to find out u minus v. So we have to subtract the vector v from u. Same method for the subtraction. In the third part, we have to find out the actually the magnitude of the scaling vector, right? What is the scale factor here is 1/2, और वेक्टर हमारे पास कौन सा है? वो u है. अब इसको सबसे पहले हम, आपको पता है कि जब भी कोई चीज़ सॉल्व करते हैं तो हम ब्रैकेट्स अगर हो तो उनको पहले ब्रैकेट के अंदर वाली चीज़ों को पहले सॉल्व करते हैं. सिमिलरली हम यहाँ पे हमारे पास हाफ u है, इस चीज़ को पहले करेंगे. अभी आप मॉडुलस को भूल जाएं. तो हाफ u का मतलब है u की वैल्यू को सब्स्टिट्यूट किया वेक्टर की, और हाफ को अंदर मल्टीप्लाई कर दिया, राइट. हर एक कोऑर्डिनेट एक्सिस के साथ मल्टीप्लाई होगा. क्लियर है? अब इसका जब ये सॉल्व हो जाएगा ब्रैकेट के अंदर वाली चीज, अब हम देखेंगे कि इसका क्या लेना है हमें, मॉडुलस. और इन मॉडुलस इज एक्चुअली इक्वल टू इन 3 कोऑर्डिनेट सिस्टम square root of x square plus y square plus z square. So taking the squares of x, y and z, we got 1/2 square root of 12. In this slide, we will know how to specify a vector. So vectors can be specified in a Cartesian plane in 2 ways. A vector can be specified by representing if we are given with its magnitude and a direction theta. If you can see in the figure 1, in xy plane we are given with the magnitude of a, and it is inclined through an angle of uh, theta degree. So we can specify the value of vector. Similarly, another way of specifying is specifying a vector if we are given with the xy components, as x component of any vector is represented by ax. Similarly, if we have a vector y, then its y component will be represented by ay. As you can see in the second figure, in xy plane, if we are talking about the ax, x component of a vector A. So that is actually the horizontal length of vector A along the x-axis. Similarly, if we are talking about the component AY, it is the vector A which is in the direction of y-axis, which is actually in the direction in the vertical direction. So these are the ways to specify a vector. Uh, Now we learn the two ways to specify a vector and how ax equal to a cos theta, ay equals to a sin theta. These values can be obtained by using the Pythagorean theorem. As you can see in the figure, the x component of the vector a and the y component of vector a are specified in this figure. The magnitude of A is found by using the Pythagorean theorem, which is mod of A equals to square root of ax square plus ay square. The length of a vector clearly does not depend upon its direction, and the values of ax, ay you can easily obtain by using the trigonometric ratios. If we are given with the components of A along x or y along x or and y axis, and we want to find out the direction of the vector, then it can be find it out by using the formula tan theta equals to ay over ax. Now the theta becomes tan inverse of ay over ax, and x is in the subscript, not it is multiplied with it. As we have defined earlier, these are the components of a vector. In the next slides, we will discuss the component of a vector in two-dimensional space, how we can resolve a vector in two components. As we discussed, or you all are familiar about it, that a vector A is divided into the components, and the components depend upon the number of x's. If you are in a Cartesian plane of dimension 2, then obviously you will have the two components ax plus ay. As you can see that you are in you can see the figure in the xy plane, so the vector can be resolved into components ax and ay. So the vector A can be written as sum of its vector, or sum of its vector along x-axis plus sum of its vector or the component of the vector along y-axis. You can say that. Similarly, we have component of a vector in three-dimensional way. If we are talking about the component of a vector in three-dimensional space, or obviously it can be resolved in three axes, ax, ay, and az. As you can see in the figure, a vector A is resolved in the x direction, y, and z direction. So it has components ax along the x-axis, ay along the y-axis, and az along the z-axis. Similarly, you can see the unit vectors represented in these three coordinate along these three coordinate axes respectively. So the vector A is expressed as ax I cap plus ay j cap plus az k cap. The components don't have the vector symbol. Only the vector has the vector symbol, right? The components Fa are represented by mod of Ax, which is actually can be written, and magnitude can be written in the form of Ax. Magnitude को आप mod में लिख लें या उसके बगैर लिख लें और उसके ऊपर वेक्टर सिंबल नहीं आता, ठीक है, तो वो किसके इक्वल हो जाएगा, A cos theta. Similarly, we have the component of vector A along y-axis, which is equal to ay, and it is equal to A sine theta. These values can be obtained by using the trigonometric ratio, as we have a right angle triangle, so we can apply the trigonometric ratios here. So the magnitude of A becomes ax square plus ay square whole square root, and the direction of A obviously given by the theta, which is equal to tan inverse ay over ax. Unit vector notation for a vector: A is written as A cap, a vector symbol equals to component of A I cap plus A Y j cap, or it can be shown in the figure. So if we are given with the vector A and B and these three vectors in the three-dimensional space, how we can add these three vectors with the help of their components. So similarly, in the same way, if we have to add two vectors, we can add the x coordinate and the x coordinate, y in the y coordinate, and z into the z coordinate. Similarly, if we are given with the components of the vectors along x-axis, y-axis, and z-axis, we will add the x component of A and x component of B with each other, and similarly we will add the y component of A and B and z component of A and B. So we got another vector C. Two vectors, when two vectors are added, they will give another vector, that is some third vector. You can say it C. As you can see in the equation, C equals to sum of two vectors A and B, substituting the values of A vector and B vector, and we got their sum. As I have explained you, the x components of two vectors are added, and I cap will be the common direction. Similarly, y components are added, and in the third term we have added the z components. So when ax plus bx are added, they gives you another component, say cx. Similarly, ay plus by is added and it gives cy component, because we have said that a plus b gives you the vector c. So these vectors must be the these components uh, must be the components of the vector c. Next topic is dot product. Dot product is also called the scalar product. If two vectors are added, now we are defining the operations on these two vectors. How these vectors will be added, multiplied, subtracted. Similarly, we have another operation, that is the scalar product or the dot product. If we are given with the two vectors a b, then their dot is defined as mod of a vector mod of b vector cos theta. Dot product or the scalar product have some properties, as we have defined that a dot b um, equals to magnitude of a, magnitude of b cos 90, and magnitude can be represented equals to a, and magnitude of b can be represented in the form of b. So if the angle is 90 degree, that if the two vectors are perpendicular to each other, then what will be the result of their dot product? If two vectors are perpendicular to each other, then their dot product will be 0. How it can be 0? As you know that cos 90 degree is equal to 0. When 0 is multiplied with the magnitude of two vectors which are multiplying, so the answer will be 0. If the magnitude of the dot product is equal to 0, that means the dot product of two vectors is 0. Similarly, we have the case if the two vectors are parallel. They are in the same direction, so their cos 0 becomes 1, and the answer will be AB, right? So the magnitude of A dot B will be maximum. if they are parallel to each other. So the minimum value of the dot product is when the two vectors are perpendicular to each other. Similarly, we have another property of the dot product, that is the commutative property, or the vectors in vectors, how we the property is said to be commutative if a plus b vector is equals to b vector plus a vector. Similarly, we have the distributive property over the dot, how use the distributive law to evaluate the dot product if the components are known. A dot b इक्वल्स टू, अगर अब आप उसका डॉट कैसे डिस्ट्रीब्यूट कर सकते हैं, ए डॉट बी है, बी वेक्टर है आपके पास, ए वेक्टर आपको पता है कंपोनेंट फॉर्म में किस तरह एक्सप्लेन करते हैं, इसी तरह बी वेक्टर को कंपोनेंट फॉर्म में डिफाइन किया एंड ऑपरेटिंग डॉट वी हैव उसको बिल्कुल उसी तरह बिहेव करना है जैसे हम मल्टीप्लाई या मल्टीप्लिकेशन में करते हैं, तो एक्स कंपोनेंट्स को मल्टीप्लाई कर दिया और डॉट आ जाएगा बिटवीन आई डॉट आई. सिमिलरली ए वाई बी वाई जे डॉट जे ए प्लस ए जेड बी जेड के डॉट के. और आपको पता है if the vectors are in the same direction, then their magnitude will be, their dot product will be equal to 1 as I dot I. The magnitude I dot I किसके equal होगा? The dot product of two vectors is equal to mod of I cos 0. Why there is a zero angle between these two vectors? Because these two vectors are same, so they must be parallel, so they are making an angle of 0 degree, in cos 0 equals to 1, and the magnitude of the unit vectors are equal to 1 as we have studied it earlier. So the equation become ax bx plus ay by plus az bz. We are only left with the product of the components.